Okay, so let's start diving into some of those details a little bit more so that we can really understand a lot of the security that's inherent in how this works from an SSH perspective. Okay, so some things that I'd like us to see next back on the server side is really to understand some of these other files that are in this /etc/SSH. All right, so in other words, we were looking at the configuration files, and hopefully you can start to understand these are things that will tweak the behavior of your SSH server itself. Well, what about all these other files? What are these files? This SSH_host_ECDSA_key. Like, what are these key files that you see here? Key.pub. What are all these other files? And a lot of this comes back to, let's first understand the fundamentals of encryption, right? This is a secure communication. That's the whole point of SSH, is to establish a secure communication, which means it's going to be encrypting the data. Well, how? How is it going to be encrypting the data? So I want to jump back to a quick little graphic just so we can make sure we wrap our head appropriately around the importance here of these key files. So what we're really talking about here, of course, is asymmetric encryption. So as a quick refresher of asymmetric encryption, remember the whole point here is that you have a pair of keys. That's the whole point of asymmetric encryption. And so these keys are related, and many times they will label the files in Linux. You will have something called the key, and then you would have another one called with the same exact name called key, and then .pub. And what we have here is a pair of keys, oftentimes thought of as the private key and the public key. Again, pair of keys that go together. And the whole point is any data that you encrypt using one key, you can only decrypt it using the other key. And vice versa. Any data you encrypt with one key, you need the other key in order to decrypt it. So if you only have one key, you can encrypt the message, but you would not be able to decrypt your own message unless you have the other key. So understanding that these keys come in pairs is really, really important. And so if we take it a step further and say, well, how is this being used from an SSH perspective? Realize the server, as we just saw in that folder, it has a bunch of key pairs. And so whenever a client computer shows up to the server will offer the public key. It's going to say, here, you use this public key. And so what this allows me to do is that if the client is given the public key from the server can then encrypt data using the private key. And then the client will actually be able to decrypt it because it has the public key, and vice versa. If the client goes and encrypts data using the public key, the only one who will be able to decrypt that data, of course, will be the person who has the private key, which ideally would only be secretly held by the server, as we just saw right there in that folder. So understanding these keys is paramount to understanding the security of SSH. All right, that understanding that our SSH servers have these keys, and this is what different clients can use when they connect to the server. We're connecting, and that's what when we saw that when we connected on the Kali side, it offered this connection, be like, hey, here's some information that you can use. You'll be able to use this to decrypt messages I send to you. And of course, I'm going to require you to use this when you want to send encrypted messages to me, and no other computer in the world would be able to do this. All right. And now here's kind of a next important thing to understand is that, computers, SSH servers, like they have multiple keys. Multiple pairs of these keys. And what I've tried to identify here is, you can see they don't all use the same algorithm. So one pair of keys might use this RSA algorithm, one might use this ED25519 algorithm, one might use this ECDSA algorithm, and you'd really have to get kind of into a crypto lesson to really learn, okay, what are the differences between these algorithms? Some of them have some pros and cons. Sometimes an algorithm is just flat out better. It's better to use one algorithm as opposed to another. Now, for the purposes of what we're doing today, without getting into a big crypto lesson, I'll simply say, as long as your keys are long enough, then it creates a secure connection, at least by modern standards. Now, long enough is kind of relative. That can change over time, and this is why we start to see some algorithms falling out of favor and other algorithms becoming more important. The promise of quantum computing is obviously starting to threaten some of this stuff, to be like, hey, what's this going to do to the future of some of our keys and some of our algorithms and how we use them? And I guess what I would recommend that you learn more about, obviously, is just cryptography in general, but would be to learn about what does the NSA recommend. right? The NSA is one of the authorities in the world when it comes to cybersecurity, and they have some recommended algorithms with recommended key lengths. And so I'd say, hey, if you're doing what the NSA recommends to secure data, you're probably doing the right thing, all right? So anyways, we have these different keys. Next, I want us to understand that the keys on my server, they could be different than the keys on your server and the keys on somebody else's server. Like, that's the whole point. We could be using the same algorithms, but you're going to have your own uniquely generated key pairs that are going to happen every single time. Okay, so let's jump back over to our computer here and kind of notice this stuff. It's like, that's what we're looking at. We have this SSH_host_ an algorithm key and then a key.pub. All right, and so this is a pair of keys that you have that will work together, where the server will offer you one along with some other information, and it will use that private key to be able to decrypt your data. Okay, so if I wanted to maybe take a look at one, yeah, sure. Like, we're just kind of learning here. This is not something you might normally do in practice, but if you wanted to look at one, like, sure, let's take a look at it. All right, and we'll see here if we try just like catting one of these out. Maybe I'll try like looking at the RSA key. Sure, I might try doing something like this. I could do like a nano into that SSH_host_RSA key. And you'll see what happens is that permission denied, right? This is a private key file, so realize this is something that you do not, as a normal user, you're not going to be able to come in here and see the private key that's associated with the server, right? So the whole point is a lot of these key files, they've specifically been locked down. So in other words, you have to be the root user in order to see them. Right, we could check the permissions on these things. We could do like an ls-l and see, like, yeah, a lot of these, they're currently owned by the root user. And when you're looking at the private keys themselves, no one else can read this information. All right, and that's kind of the whole point. So obviously we can cheat. We do have sudo capabilities. I could run this with sudo, right? Type out my password and be able to say, hey, there's my key file. Begin private key. There it is. All right, and so if you kind of scroll up and down, you see it's about a page to page and a half, but that's all the unique random data that would be used to be able to decrypt messages coming from your public key. Information that was encrypted there. So what I'm doing right now, of course, is something that you would never want to do with your keys in practice, which of course is showing them to the world. Because if I have this key, if I have the private key, I would be able to potentially decrypt traffic that's going back and forth to a secure connection. All right, so maintaining the security on these files is critical. That's why I'm emphasizing this and going through this. We got to understand this here as we're learning about it, but you got to really maintain the security on these. And if you think the security of your keys has been compromised, we'll get into that in a bit. It's like, well, then we'll have to generate new ones. Okay, we could also do the same thing and look at the .pub key, right? That SSH_host_RSA_key.pub. It's like, well, there it is. And you can see it's like that one's not pages and pages and pages, but it's actually written sort of on one line, and it goes for a ways. Like, it doesn't quote, it's certainly not as long as the other, but you get the idea. It's like you got all this different random data. Here it is. Something like VI might actually format that a little bit nicer for us. If I do like sudo vi SSH_host_RSA and then the .pub, you'll see that. Yeah, there we go. So it is all on one line. It's formatted a little bit differently when we use something like VI. So, but there you go. So there's a pair of keys, and those keys, they're going to be unique to me. They're going to be unique to my computer. When you get these computers randomly generated, certainly if you were to look at the keys on your computer, they wouldn't be the same as the keys on my computer, as everything, of course, being randomly generated. Now let's take a closer look at some of this information and see what it is that we want to understand as we're making these connections. So I've got these public keys, I've got these private keys. You even if you wanted to kind of learn here as we're actually doing this, maybe I'll look at one of the other keys as well, right? I could look at like one of the hosts. Maybe I'll look at how about the ED25519_key, and you see that key is much shorter. Right? It's still a private key, but it just is significantly shorter. And if you want to learn why is this key shorter, I'd say, well, you got to go learn how the algorithms work. And the whole point is, as long as the key is long enough for that algorithm, then we say that that's secure, right? And I can look at the .pub key, and you'll see again that this one's significantly shorter relative to the RSA keys. But this is a lot of, we're skirting around the edges of how the crypto actually works. What we need to practically understand is the keys that are in this folder are really important, and there's multiple algorithms. There's more than one that you'd have to kind of go and pay attention to. Okay, fine. Let's kind of start to see some of this information and confirm this here on the Kali side. So one thing that should happen as we're creating secure connections to other computers is you'll actually get some other folders that will start being created on the client side, not on the server side, but on the client side, right? And you can see some of these usually in your home directory by doing an ls-a, right? ls-a will show hidden folders. So if we just did an ls, it shows the folders that are there in my home directory, right? Desktop, documents, downloads, and all that. Well, ls-a shows, hey, you've got a bunch of other stuff in here. And a lot of them start with a period. So realize in Linux, any file or folder that starts with a period, that makes it hidden. And so that is a valid name to have your file name start with a period, but it won't show up unless you toss on the -a option when you run your ls command. It's like, oh, okay. And so the one that I specifically want to hone in on is, well, how about you'll notice there is a folder called .ssh. So after I've created a secure connection, it might not have been there before, but after you've created a secure connection, in your home directory, you should now have a hidden .ssh folder. And you could cd into this folder, right? I could cd into .ssh. That's a valid thing that I could go to, right? If I check my directory right now, pwd, I'm in /home/sandbox/.ssh. Sure, you can have periods as the start of the file name, or as the start of your folder names, and that's valid. Now let's take a look at what's inside here. Let's do an ls. And right now, we should have one file that's in there, one file called known hosts. It's like, oh, okay, so think about it. We're the client, we connected to a server, and now that we've connected, I have a known hosts file. So as a client, you will keep track of the different servers that you connect to. And this relates to that message that we saw when we very first connected, right? When we very first connected, it gave us this message. Hey, I've never seen this device before. The authenticity of this host can't be established. It's offering an ECDSA key fingerprint of this. Do you want to proceed? Do you want to accept this connection? So effectively what happened is your SSH service on the client side looked and said, have you ever seen this server before? Have you ever seen the key information that it's offering you before? And if the answer to those questions is no, then it tells you, hey, you're connecting to something that I haven't seen before. Do you want to accept this connection or not? And we said, yes, we want to accept this. So we had to understand the encryption there was not using all of the available keys. It wasn't using all of them. It picked one and was using one. And we can see it was using the ECDSA when I went and established that connection. Right? ECDSA, there it is. That was the key that was actually used. So it's not going to use all the keys. It's only going to use one. All right. Okay, so I could go ahead and take a look at this. Let's take a look at what's actually inside the known host file. I'll cat it out. Cat out known hosts. And you'll be able to see it's like, hey, there's some information, some of this crypto stuff that was offered to me. It's like, oh, okay. What does all that mean? It's like, well, you've got entry number 1. Here's some information that was offered. And then it says ECDSA using SHA-2, like here, and then here's some more information. Again, some more kind of crypto jargon. It's like, well, can we tell what this stuff actually is? It's like, well, if we scroll back up to the top here, where we initially established that connection, let's take a look at some of this information here. You'll be able to see it offered you a fingerprint, remember, and we were using the ECDSA as the connection, all right? So if we come back down here to the bottom, we want to understand that, okay, I've got this information, ECDSA, that's what was offered to me. It's like, well, let's take a look at this information on the server, right? On the server, we were just talking about this ECDSA_key.pub. This is one of the keys that we currently have. So maybe I'll try catting it out. Cat out the SSH_host ECDSA_key.pub. And you'll be able to see it's like, hey, ECDSA, SHA-2, NIST, 256, here it is. And now here's a bunch of information. All right, and you can kind of go and confirm and like look at how this file ends when you look at the end of the crypto jargon before you get to like the usernames as to who this key was for. Right, you've got this JNIMPJK =. Right, and if I jump back over to the previous computer, you'll see it ends right here, JNIMPJQ =. Right, so this information right here that you were offered from this computer when you connected, this is the public key. And it will keep track of this public key so that if I connect to this computer again, right, if I try the SSH connection again, SSH to sandbox at 192.168.8.2, and I type in my password. Notice it didn't ask me, do you want to trust the server anymore? Because it had seen it before in the known host file. Right? So paying attention to what actually shows up in your known host file, it's a way to have your client computer start remembering the servers that they've connected to in the past. Now, okay, this is important to realize. You might also realize, like, hey, James, I thought you said a moment ago that my key information should be different than your key information. And if you took a close look at some of your key information, if you actually cloned out your own mini hack and looked at it, like, you'll notice that, yeah, you probably have a lot of the same key information that was being used. And of course, the reason why is because you have gotten a clone of my computer, right? When we clone out these mini hack computers, you're getting copies of the same computers again and again and again. So the keys were randomly generated when the Ubuntu computer was created and when everything was first installed, but then it was copied from there. So you definitely want to be cautious and real careful about when somebody gives you a computer, is this a copy? Because if the computer is a copy, it's like, well, it could have information that's actually duplicated across other computers. And so this is where it becomes really important to understand, like, well, what if I needed to maybe generate new keys? What if I wanted my keys to be random from your keys? It's like, well, that certainly would be a good thing to understand how to do. So, of course, this is something that would be done on our server side. And we'd have to realize there are some commands we can run to generate new keys. So if I wanted to start generating new keys, this is a really, really useful command to learn how to do. So it will require sudo, because we're going to be making a kind of a change here to our key files, which of course are owned by the root user. And there is a command called ssh-keygen. So learning about your ssh-keygen command, this one is going to be a really, really useful command to learn about. So as you're generating new keys, what you're saying is, okay, I've got 3 different types of algorithms, but apparently my keys have been copied. And I want to generate new keys, maybe with those same algorithms, but I just want to make sure that mine are new. Mine are different. Mine are completely unique from everyone else's in the world. They're different from you. They're different from a previous installation that I've done. Every time we run this ssh-keygen, you're going to randomly get new keys. It's not mathematically possible for you to be able to possibly get randomly generated to another key. Because as you see here, it's like all of this information would have to be completely randomly matched to someone else. And that's just, statistically, that's not going to happen. Okay, so we've got our ssh-keygen command, and what you're going to want to specify is the -t to say, well, what type of key, right? We see there's 3 different algorithms that our SSH server here wants to use, so you could specify what type of key do you want to reset or create a new one for. So maybe I'll do that ECDSA. Apparently that's the one that's being used, so I'll say -t and then ECDSA space. Okay, so I'm going to generate a new ECDSA key. Well, where? Where do you want to generate this key to? So you could generate keys. You could use this ssh-keygen command. You could generate keys and go use them for other things. You don't have to generate keys and make them the keys for your server. But that, of course, is what we're looking to do here. I'm looking to generate new keys and make them the keys that my server will use for secure communications. All right, so in other words, I'm going to have to do a -f to specify where will this file go. And what I am going to do is I'm going to overwrite the existing keys. Like those existing keys, they've been copied, they've been compromised from a security perspective. So let's go ahead and generate new ones. So where are those files located? They're located at /etc/ssh/ and then it's, well, ssh_host_ECDSA_key. Right, that's the main private key file, and that would be the location where what you would specify for your file path. So I'll do ssh_host_ECDSA_key. All right, and when I run this command, it will say, hey, there's already a pair of keys there. So it notices the key and it notices the key.pub. It's like, do you want to overwrite this? And I'll say yes. Like, I know those keys are compromised, so I'm going to overwrite them. If you want, you can create an additional passphrase on top of things to be able to use these keys. For the server, for what I'm setting up right now, I'm going to keep things a little simple. I'm going to say I'm not going to have an additional passphrase to use the key in the first place. So I'll just hit enter. I'll leave this one blank. I won't have a passphrase. again, I'll just hit enter again, and it'll say, hey, we just went and generated a new key. Here's your new fingerprint for the server. And they kind of come up with some silly little ASCII art to show you, like, here's the random art that represents the key that was just created. And if you take a look at your art and compare it to mine, you'll see like your art is going to definitely be different when you run this. Every time you run this command, you're going to get a different set of keys, different set of art. Nothing is going to be the same from now on once you run this. So we might have been the same from the start because our machines were copied, but going forward, we're going to have everything is going to be unique. And of course, we can try to like confirm this now. Maybe I'll cat out that public key again. I'll hit a couple up arrows here and I'll cat out my public key from before, right? And again, just kind of looking at some of the last characters. Yeah, I could look at here and say AL/YIAK =, and like compare that to what was in the known host file from before, right? If I cat out my known host, it's like that. Yeah, this one was JNIMP, like completely different. I now have a key for my ECDSA algorithm that I'm using right now that completely different than what was offered just a moment ago. And of course, from a security perspective, I'm not going to show you my private key, right? So the public key, that one could be distributed among clients as they connect to me, but that private key, like, nope, that one remains a secret. And this is why we want to make sure, like, no one should get access to these private key files, of course, unless they're the administrator, and that's why they're locked down the way they are, so that only administrators can mess with the keys for a given server. Okay, so let's go ahead and now see the effects of this. Now that we've generated a new key, what happens if we try to SSH again? Right, if I hit a couple up arrows here and say, let's try to SSH back to this computer again. And if I try this, host key verification failed. I get this big scary message. Remote host identification has changed. Is it possible someone is doing something nasty? It's like, wait, what? What's going on here? And of course, what's happened is your computer went and said, hey, I've connected to this server before. And the keys that it is offering to me, that public key is not the key that I saved in my known host file. I've seen this server before. I've seen this server, and it's now offering different keys. Why? Why is this server offering different keys? Is someone, as they're kind of saying here, is someone doing a man-in-the-middle attack, where someone is trying to sneakily pretend to be the server, and it's giving you a big warning here to say, are you sure you're connecting to the correct server? Because we've seen the keys for the server before, and they're not the same anymore. All right, so this is kind of a scary warning, and you'll realize that without an extra options to completely ignore this scary warning, this will not let you connect. Notice it did not prompt me for a password. It just said verification failed and said, nope, try again. All right, so you kind of have two ways to solve this problem. One would be to realize, like, okay, I do actually still trust this server. I understand I'm the one who generated the new keys, and what I'd like to do is delete my known host file. Right? If I delete my known host file or simply remove that entry that was on the known host file specifically for this server, then I'd be able to say, well, I'm going to approach the server fresh again. Like I said, another alternative would be there is an option you could add on for SSH to override I think it's called like strict host key checking or something like that, where you could say, all right, I'm not going to actually verify are the keys the same as what they did last time. Whatever the server offers me, I'll trust it. All right. So, and again, you really should only do that if you truly understand what's happening. You shouldn't have this message popping up and just ignoring it at a whim. So what I'm rather going to do is say, yep, my known host file, yeah, this was created by SSH, but this is okay to delete. All right, and especially now because I only have one server that's in my known host file, and apparently this information is now out of date. So it isn't a problem to come into your location and say, well, I'm just going to remove my known hosts. Right, and now it's gone. Right, I no longer have this known host file, just a rm _known _hosts, and the file, of course, is gone. And so what this means now is that if I try SSHing back to this server, it's going to say, hey, I've never seen this server before. In other words, it wasn't in my known hosts because my known host was gone. And I could say, yes, I'd like to now trust this server. Go ahead and log in now. It did not give me the big scary messages saying that there was a key mismatch. And that's, of course, how a lot of our key authentication authentication is very, very critical for making our SSH servers work. So that known host file, this is a critical file. It's one you want to understand, but realize in some ways it's okay to kind of clear it out. It's okay to delete it in some cases because if you have a key mismatch and you know that you were the administrator who reset it, then realize that that's what's going to happen. Also, as we're thinking about this from the server side, you have to understand every single time you run this keygen command, like if you run keygen and you generate new keys for your servers, any clients that try to connect to you, they're going to get that scary message now. So you really should be anticipating that. You should anticipate if you ever have to generate new keys for your server, make sure you inform your clients. Like, hey guys, you're going to have to delete this out of your known hosts, or some change is going to happen, or maybe you, if you're the administrator and can control some of their company computers, maybe you would go and correct that problem for them. Like, you got a variety of options, but just realize if you make changes to the SSH server and people have connected to your SSH server before, then this could start creating a conflict. So yeah, you could go through and generate new keys for the others as well, right? You could generate a new ED25519 key. You could generate a new RSA key. That keygen command, that's a really cool command to be able to learn about as you're going through and continuing to master different things that you can do with an SSH server.